Good morning, guys. We've got an incredible discovery coming out of Egypt this week in Saqqara, just about 15 miles outside of Cairo, the capital of Egypt. They found a burial shaft that had 13 wooden coffins, and there may be more. They're still investigating this. And coffins are in this area that's called a necropolis. Think like a massive city-sized cemetery. That's what Saqqara was. It was the giant necropolis outside of Cairo. And a lot of people got buried there. What's in the coffins? We don't know, and we're hoping to find out soon, but there's a good chance there's some type of mummies in there. Now, mummies, when you think of mummies, you probably think of the big, rich, powerful pharaohs of Egypt, the ones that had the money and the power to be able to afford that. And when they first started out mummifying people, it was pretty expensive and only the rich and powerful could. But preserving a body for the afterlife ended up becoming cheaper and cheaper as time went on. So the average person was able to afford mummification. Let's look at how a mummy is made. One of the ways to make a mummy is by treating it with something called Natron. Natron was a salt that was found in Egypt. So Natron is a type of salt. This molecule, NaHCO₃, it absorbs the water from the body. So you've got C, the carbon, you've got O3, that is the 3 oxygen, you've got a hydrogen attached to one of the oxygens, and then you've got little Na, which is sodium, that would attach and try to piggyback onto one of the oxygens. That was the molecule. And you needed a molecule that would absorb water. Water is H2O, and H2O looks like this. We got 2 molecules, or 2 atoms of hydrogen and 1 atom of oxygen. Whenever there's liquid water, there's a chance for bacteria to grow, and bacteria are a decomposer. They will take those bodies and break them down into smaller and smaller pieces. We don't want bodies to break down if we're trying to create a mummy. By packing salt in there, we can slow down that process or maybe even prevent it altogether. The salt you're usually familiar with is this salt. We call it table salt, and that is made out of sodium and chlorine. We put these two together, that's NaCl, that's table salt. 1 atom of chlorine and 1 atom of sodium put together forms 1 molecule of table salt. If you put 3 of those molecules together, you end up with a chain of table salt. You add more of them together, you end up with a matrix, basically a cube, a crystal of salt. So salt is a matrix of alternating atoms of chlorine, sodium, chlorine, sodium, chlorine, sodium, chlorine, sodium, alternating, making a cube, a crystal of salt. Molecules of water start to attach. The oxygen side of the water molecule is attracted to the sodium, and the hydrogen side is attracted to the chlorine. If we put a molecule of salt next to a molecule of water, something strange happens. The molecules have atoms that are like magnets. So just the same way as a magnet has one side that is attracted to, you have another side that is repelled by, and it doesn't want to attach. The 2 hydrogen atoms have a bit of a positive charge and they want to connect to the chlorine. The oxygen has a bit of a negative charge and it wants to attach to the sodium. Remember that positive and negative forces attract. And it's not just mummies. We can preserve lots of things using salt. So here's a cucumber from my vegetable garden. Let's see what we can do with adding salt and other substances to it to experiment to see what makes the better preservative. Hi, so for this experiment, we're going to call it the salted cucumber. This is something where we're going to experiment to find out how does salt take moisture away from an organism. All right, we've got 4 cucumbers that we are going to measure. We are using cucumbers because cucumbers are like 94% water. They've got a lot of water in them, so we can really measure. Weight, WEIGHT. So the first data we'll take is on the weight, and we'll do cucumber number 1's weight, 31 grams. So cucumber number 1 is going to be our control. This is the one that we're not going to make any changes to. We will measure it again at the end of the experiment to see what changes happen to it, but we're not going to make any changes to it. Cucumber number 2 is 30 grams. And cucumber number 2 is the one that we're going to add baking powder to. Our third cucumber, 31 grams, and we're going to add sugar to it. Our fourth cucumber, 27 grams, and we will add salt to it. Cucumber number 1 is 31 grams, and it's going to be our control. We won't add anything to it. Cucumber number 2, 30 grams, and we're going to add baking powder to it. Cucumber number 3, 31 grams, we're going to add sugar to it. Cucumber number 4 is 27 grams, and we're going to add salt to it. 1 teaspoon and put it on the cucumber. Scoop of sugar, 1 teaspoon of sugar. For the cucumber number 4, we're going to pour some salt, measure some salt. So after taking off some of the saturated, absorbed powders, we're going to add 1 more teaspoon of sugar to cucumber number 3, and 1 more teaspoon of salt, cucumber number 4. Can you go ahead and put that on cucumber number 4, please? It is about an hour since we started our experiment. Our control, 29 grams. Baking powder is 31 grams. The sugar cucumber is 30 grams. The salt cucumber, 25 grams. So that gave me some idea of how salt can take water away from a substance. It took it away from the cucumber. We saw that sugar actually took water away from the cucumber. Baking powder, not so much. But let's take it a step further. Let's see what happens if I leave cucumber in salt overnight. As I pull it out, I notice that the salt is really chunky all the way through. Cucumber isn't hard, but it's only a bit shriveled up. Mass of 8 grams. Wow, that lost a lot of mass. It started out at 26 grams and it went down to 8 grams. That means it lost all of that mass in water. Coming back to our mummy, to preserve the body, they would take out the brain first, which they didn't think was important, so they would actually pick it out through the nose in tiny little chunks, and they would set it aside because they said, we don't need that. Then they would take all of the vital organs out, and they would put them in jars. All of the vital organs that they thought were important, they would put them in jars with some natron to start to preserve them, and they would soak out all of the water from those organs. And they would wrap the whole body in packs of natron that would soak up the water, and then they would remove those, and then they would wrap the body in a resin-filled cloth. And so the resin-filled cloth would be like think of it like a wax. Resin is the kind of thing that plants will use if they have an injury. Like think of tree sap where a limb broke off. And it makes a barrier that's going to be watertight to keep out any water that might allow bacteria to absorb into the body. All right, guys, go ahead and check out some of these links, learn a little bit more about mummies and how salt acts as a preservative for them. Have a great day.